Imagine that analysis of sensor data from a gas turbine indicates that performance of its drive shaft might degrade in a week. Your maintenance team needs to find information on similar events to diagnose the problem and determine which spares are needed to fix it. Unfortunately, your conventional search solution couldn't find relevant information because none of your gas turbines have experienced this problem before. In the end, the team prepares a work order based on limited information. However, your databases actually contain reports and emails on centrifugal pump drive shaft failures, as well as generic failure mode data from OREDA. Is there a search solution that could have found this data? Well, a centrifugal pump is a type of rotating equipment. Similarly, a gas turbine is also rotating equipment. A system that captures this ontological structure could find and recommend that you review the centrifugal pump failure report, even though you only searched for gas turbine failures. Keyword or word embedding based search engines like Elasticsearch fail to find this data because they are unable to effectively capture the full depth of domain-specific ontologies. Experts on your team might consider searching for failures in other rotating equipment, but the process will take more time if they need to search multiple databases separately, or the search turns up many false positives. Even a search solution using ChatGPT alone wouldn't work, because the first step still involves indexing and searching using word embeddings. What you need is a search solution powered by knowledge graphs. Let's take a look at how this works. Using natural language understanding, Senozai's search system recognizes that your query is related to gas turbine, drive shaft, and failures. Since your databases don't contain direct information about gas turbines, the system returns the best match according to keywords, but suggests to the user to broaden the search by including rotating equipment in the query. Our knowledge graphs respect ISO 15926 for faster discovery of related equipment failure events. With that revised search, the system serves the centrifugal pump failure information to your team. The knowledge graph could also recommend spare part suppliers, show related systems that will be shut down for the fix, and identify dependencies of the failure to prioritize the fix. Now, you can make better, optimized decisions around the failing drive shaft, as well as maintenance you could perform on other equipment in shutdown systems. With the support of knowledge graph technology, you can gain faster, more complete access to critical information across a spectrum of sources, from internal databases to public resources such as OREDA. To learn more about the power of knowledge graphs, visit us at senozai.io.